Lesson 12, it's all on the line. Our aim today will be, let's use minimal information to create equations for lines. Okay, so 12.1, parallel and perpendicular. The image shows line N. 1. Write an equation for the line that is perpendicular to N and whose y-intercept is 0, 5. Graph this line. Well, one thing I should just point out, really we should have arrows at the end of the line here, because that implies that it goes on forever, and it is a line. It really looks more like a line segment when you don't put those arrows there. So we want something that's going to be perpendicular to this line. So if you remember, we use slopes to determine if a line is perpendicular to each other. So if two lines are perpendicular, the slope, if one is A over B, the slope perpendicular to that will be negative B over A. And we call that the negated reciprocal. All right, so I need to find the slope of this line N. So I can pick any 2 points I want. They give us these 2 points here, so those are the easiest to use. And I'm going to find the rise over run, or the delta y over delta x. I'm trying to find the slope of line N. That M just means slope, and then the subscript N means it's referring to the slope of line N. So in the y direction, we're going down 2. So the change in y is negative 2. And in the x direction, we're going over 1, 2, 3, 4, 5. So that's negative 2 over 5 is my slope. All right, so we're going to find the line perpendicular to this, and they give us a point. So if they give you a point, and I already know the slope now of this line, this is going to be the negated reciprocal of 2 over 5, aka 5 over 2. I can use point-slope form. So if you remember, point-slope form is y minus k equals m times x minus h, where m is the slope, and h comma k is some coordinate, some point on the line. So my y coordinate is 5, my slope is 5 over 2, and my x coordinate is 0. I can also just rewrite this as y minus 5 equals 5 over 2 x, because x minus 0 is just x. 2. Write an equation for the line that is parallel to N and that passes through the point 3, 1. Graph this line. So parallel lines, that means same slope. So my slope is negative 2 over 5, so I'm going to use that same slope. And again, use my point-slope formula to get my equation for this line. My y coordinate is 1. Slope is negative 2 over 5. And the other x coordinate is 3. So I'm going to graph both these, and I'll show you a little trick for doing that. Normally when you've been graphing, especially last year, you would have used slope-intercept form. So what I can do instead, because it's going to be a decent amount of work to put it in that form, I'm just going to start from the point. So 0, 5 I know is on the line. 0, 5, it's right here. And then I know the slope is up 5 over 2. So actually it's going to be difficult because I can't go up 5 here. I can go down 5 and back 2 though. 1, 2, 3, 4, 5 over 2. 1, 2, 3, 4, 5 over 2. So I actually can graph that line. And let's call this, it really should have given us a name, but I'll call it, since that was N, we'll call this, maybe let's call this line P. So I'll label that with a P. All right, and then for this one, we'll use that same method, although we've got a different slope, and I'll call this line Q. So I know that the point 3, 1 is on the graph. So 3, 1. And I know my slope is down 2 over 5. So from that point 3, 1, I'm going down 2 over 1, 2, 3, 4, 5. If I want to go in the backwards direction, I would go up 2, back 5. 1, 2, 3, 4, 5. And we can see that that appears to be parallel, and it should be. They've got the same slope and then perpendicular to this line. So what's interesting about this is if we look at line P and Q, they also appear to be perpendicular. So we know that from the way we've set up this problem that N is definitely perpendicular to P, right? These two lines are perpendicular. They form a right angle. And we also know that Q is parallel to N. So it's interesting, we can say now, since Q is parallel to N and N is perpendicular to P, we can say that Q is perpendicular with P as well. So we also see that makes a right angle. I wouldn't call that the transitive property. Actually, I don't know what that property is. I've never seen that in a proof, but you can say that parallel lines are perpendicular to the same line. All right, that's all for 12.1.